Hi everyone, here is another video on how do we migrate data from an on-premise SQL Server database into AWS Data Lake. So this is one of the hot topic and a lot of companies are actually moving their data warehouse from SQL Server or Oracle or any other traditional databases into cloud. So for this demonstration, I have chosen Amazon Web Service, which is one of my favorite. Let's get started. So before that, if you're new to my channel, please subscribe to my channel so that you get notified whenever I publish new videos, so that you can learn and do better things. All right, so let's get started. So here is one real-time project scenario wherein you may have a data warehouse solution which is built on SQL Server or Oracle or any other relational database systems having multiple dimensions and fact tables, and you may be having certain applications dumping data, right? And you may not have any challenges when the data volume is low, but as and when the data grows and you have more and more interfaces dumping data, it's really gets challenging, and that's where all the scalability performance issues come into play. But for this particular demonstration, I'll be choosing Athena. So this is one of the serverless SQL-based solution which you can use it for SQL querying, like how we write our SQL queries on SQL Server or Oracle. The same way you can create external tables on top of S3 bucket, and from there you can run your SQL queries. So Redshift Spectrum is another data analysis tool, which is also SQL-based solution on S3 Data Lake. So the difference between the Athena and Redshift Spectrum is we just discussed. Athena is serverless, whereas Redshift is based on your Redshift cluster, right? Both are used for analysis purposes, but Athena is heavily used in log analysis, and Redshift is heavily used on data analysis. Analytical, you can run analytical queries and perform a lot of dashboard and aggregation, things like that. So what is a data lake? A data lake is a central repository. As you can see in this diagram, data lake is a central repository which contains data from multiple sources. So for example, we are just talking about SQL Server into data lake. So this could be one of the dimension here. On-premise data movement could be one of the source for data lake, whereas you can run your analytical queries or machine learning patterns on top of data lake. You could be getting some real-time data coming from some application kinesis, or any streaming application. All those sort of data can be stored in data lake, and you can perform any type of analysis on top of it. So I've got a small data warehouse here on one of the database called RBS Retail. So if you can see here, there are 5 tables. I have got few dimensions, and orders is my fact table. It's very simple data warehouse. Let me know if you need scripts for these in the comment section. I will be happy to provide that. So it has got about 1,000 records in each of the tables. So we are talking about 5,000 record migration into cloud. And if you look at these data, I'll quickly show you. So the region table has got country, state, city, and product has got product name, category, and the price, right? And the customer table has got customer name, email, and things like that. And stores has got store name and what's a region it is, following those type of information. And finally, the orders table is a fact table, and it contains all the IDs from the remaining four, dimension tables here. So, and it has got order amount and what's the exchange rate on it. So we can certainly make use of this data set for a lot of analytical querying purposes. So let me know. I can provide you with that. So here is one query that I have written. What I'm trying to do here is I wanted to know what are some of the top states that are making a lot of orders, right? So I'm using orders table and joining with a regions table based on the region ID, and I'm grouping it by state so that we can easily know how many records, how many orders exist in from a particular state, right? So this is one of the sample query and sample data. So what I'll do now here is I will walk through on the talent job, which will actually read all these tables within this database and migrate all this data into AWS. And from there, we will quickly create an Athena table, and I'll show you the output of exactly the same query. The same top five analysis can be done on Athena. So for that, let's go to talent job. So I got a talent job here. On the pre-job, I'm making a database connection to SQL Server, right? And here is a connection for S3. So S3 is a storage service on AWS. That's where we will be dumping all the data and run the analytical queries, right? So there are two important things here. So in order to make S3 connection, you will need to have access key and a secret key. Those can be obtained from Amazon console. If you go to IAM section under users, you should be able to see the access keys and secret access key. So these I'll be making them inactive, so uh, these will not be very useful, right? This is just for this demonstration purposes. So that's all is needed on S3 connection. This will establish connection to storage service, and since we have multiple tables here, in my case it's five, and in your case maybe you may be having 100 tables or 1,000 tables. You can still do that using one single talent job. The way you do that is SQL Server has got its own internal metadata that is stored under information schema, right? So let me show you. So here are the tables that exist in this particular database, right? If you have 1,000 tables, it'll list all the 1,000 tables. So what I'm doing here is I'm slightly modifying this query so that I read all the table names from a particular database using query like this. So I'm just creating a key column here with hard-coded value. I'll show you why I'm doing this. And table name, I'm getting it as value. So I'm getting all the table names as key value pair from my DB input. Okay, and I'm using the existing connection we just created, right? So once we have this table is created, what I do is I'll use a component called tflow iterate, right? So this component will take key value pair. So that's the reason I was doing that key value pair generation from my input schema. So once you connect here, there is no configuration available in the tflow iterate. So it'll read all the table names, and from there we can iterate it and read each of the tables, right? So for that, I'll use another table input here. I'll just make a copy, and the way I connect using iterate. So now I have all the table lists coming from my input, and for each table I am iterating and reading particular table, right? So for that, what I'll do is I'll rewrite this query something like select star from, and I will get this information from one of the global variable. So for that, all we have to do is go to this outline section, and for each of the tables you should see something like value. So it is not listed here. So what I'll do is I'll probably try to do this directly here. Just do a plus sign and T flow and hit control space. Yeah, so here you have this value. So when you have multiple tables, when the first table is read, the value of the table name will be as part of this particular global variable, right? So what happens is select star from that new table. So let's say if you read a customer table, it will do select star from customer, right? Each of the table may have different set of columns, also different number of columns. So what I'm going to do here is I'm going to create just one column. Um, okay, since I copied this component from the first one, I will delete this. So what we need to do is I'll just create a column called all fields. Okay, and what I'll do is instead of giving this string type, I will give dynamic. So this is one of the important feature in the paid version of the software, right? So you may not get this option if you're using Open Studio. So I request you to carefully watch this. So what I'm doing here is I'm just creating one column and specifying the type as dynamic, and I will leave the DB type and pattern as is. There's no change. So this is just one single field. Okay. So one now my select star from the table query is ready. So from here, what we will do is, so I'll have one T file output delimited, and let's connect it using row main. So whatever data we have read in the dynamic column will be connected to this output file delimited, right? And if you want to look at the settings, so what I'm doing here is I'm specifying my local directory path. And what I want to do is, since we are reading multiple tables, for each of the table, I want the file name to be exactly same as table name. So if I'm writing customer table data, so data file should have the corresponding table name dot .csv, right? So this is how I'm defining my output file. And also I'll set one more settings here. If you go to advanced, just uncheck on this throw an error, so that if you rerun this job multiple times, it doesn't throw any issues. So this is how you get your data from SQL Server into your local file system, right? All we have to do now is just get this data uploaded to S3. So that is done using an S3 component called S3 put. Right, here is that S3 put component. You can just drag and drop it, so you can start uploading the data. So before we start using S3, so let's go to Amazon console, and we will quickly check the bucket name and folder name. um, so this is the just a quick background. So this is the Amazon management console view. This is the dashboard. So from here, either you can search the S3, right? You can go to S3 storage service. So under that, you will have a lot of buckets if you have one already. If not, you can create a new bucket. And just note that S3 is global. It does not require any region specific. But when it comes to Athena, that is region specific. So just pay attention there. Um, so I have one bucket already created. So under that, I'll go ahead and create one folder. Right, I'll just create it as retail lake. Okay, and then create folder. Okay, so it's successfully created. Okay, so here is the folder. So inside that, there are no objects, right? So the expectation here is when I run my job, it should read each and every table and dump data files on this particular folder. So before that, there are a couple of things here. So this is our bucket name, and this is the folder, and the way you can copy that S3 URI is using this button, right? You can do that. So let's go back to Talend. We'll bring in the S3 component here. Okay, so here is my S3 component. So I have already chosen this connection. So we established a connection. So I'm choosing this from the drop down, and I'm specifying the bucket name and then the folder name, right? So this is very much required in order to upload files onto S3. And here is the local folder file path. So even this needs to be in dynamic way as and when your flow iterate works. The same way, this variable will have the actual file name that we have dropped into our local folder, right? So we're going to use the same file. For each file that is completed, we will pick that file and upload it to S3. And another thing here is to note, this is the key field. So key field is nothing but your folder and file name information. So for that, what I'm using, since I have 5 files, I don't want to mix up all the files in just one single folder. So what I'm doing, I'm taking this variable, which is nothing but in my case order, right? Region could be one folder, product could be another folder. So this is my folder name, and I'm doing a concatenation so that we create that folder, and then we put this particular file along with the timestamp. So the reason we want to put some timestamp is that if you are running the job every day or after some time, it will actually keep adding the files incrementally so that you don't have to do full load every time. So this is mainly used for incremental loads. Okay, and I'm calling .csv for now, but there are several ways you can actually put data. You can actually compress it and you can put it, but compress file is not currently supported by Athena, so we will explore that option later. But you can certainly write your Spark program or big data batch jobs. You can put your files on Parquet, and you can use that Parquet file on Athena, right? So this is all about the different configuration on S3 put. So that's all is required. Let's connect it using on component OK, so that whenever a particular file is written, I want the same file to go to S3. Right, so let's go ahead and save it, and I'm gonna run this job. I'll go to the run tab and hit run. Okay, so the connection went through fine, successful. The first record is read, 3, 4, 5. So all the tables were read and dynamically read, and yeah, I can see that even S3 put was successful, and I don't see any errors. So let's go back to our S3 bucket and see if we have data on this particular folder. So here is little refresh key and it's not copied over. So let's see if it is created on my local first or not. So let me go to my folder. So it's currently on D drive T7 output. Okay, T7 output. Okay, so these are just created. Okay, I think okay, so the reason I know now, so it has just created a zip file. I think we enabled that by mistake. So let me uncheck this, because when we put the file, we are looking for .csv files, right? So let's do one thing. I will delete all the files and rerun this job again. Okay, so now I can see all the tables are now done. Let me see. Okay, the files are available, the CSV. Uh, okay. Okay, I think this is what has happened. The bucket that I created, I mean the folder I mentioned here is underscore lake. So, okay, so that could be the reason here. So retail underscore lake is where the data files are copied over. Yep. So here I can see customer folder with the data. So I think we ran twice. So we got the data twice, which I don't want. It's going to create some dupes in my case. So I'm going to delete all this folder again. Okay, so the folder should be empty right now. Yep, it is. I'll go ahead and rerun this job. Okay, so this is complete. Let me refresh. Okay, so now I have. All right, so this is what is expected. I have got 5 different folders, and under that we have corresponding CSV files. So the reason we want to do it this way is to segregate the data files first, which is easy to go back in time and download or do whatever with this data. Another reason is when you create a external table on top of this, it'll be just cleaner. So that if all the files are in the same folder, it might be very clumsy on the Athena query side. So we should always segregate based on the subject area, right? So let me quickly run through some of the Athena queries. So for that, I'll go ahead and open up Athena. So right now, so this is the Athena, window. So this is where you will see on the left hand side, you will see the data sources and the databases. And when you have create new tables, those will be showing up here, right? And this is the query window. We don't have to have any external tool for this querying. You can very well do it within the management console, right? And so let's go ahead and we will create those databases. So here are the scripts I just created in order to save some time. So I'm going to create a database called retail. That's exactly how it was in my case in SQL Server. So just choose this query and run it. And now we should be able to see the retail database. So we'll switch it to retail, right? And I will bring. So here is just one external table definition I'll walk through. So it's very similar to a create table DDL in SQL Server. All we are trying to add is create external table if not exist, and we're gonna give the same name so that we can run the same query, and all the column names and respective data types. The additional information we are supplying is this much. So we are giving row format as delimited and terminated by semicolon, because you remember our file output delimited chooses semicolon as the field separator, right? And line separator will be new line character, and we'll have to specify the location. So the location in my case is this is a bucket and this is the folder, and here is the table specific folder name. So I'll take these two create table statements and run it directly on Athena query window. So we'll just run it one by one. Run this query successful. So for running all the DDLs, there is no charge. It's free of cost. All the DDL operations are free. But as soon as you start writing your DML statements, that's when it gets crazy, and it costs a lot of money. If you are experimenting, I would warn you. This is not free, but you can just watch this video carefully so that you can just learn from it. Okay, so on the left hand side you see the database, the retail database, and here are the two tables that we just created. So when you expand, you will see all the column names along with the data type, right? So I'll go back to my SQL Server world, right? So we had this top 5 query. So basically what this is giving the top 5 states with highest order count. order count based on the state. So I'm gonna run the same query. I'm gonna run the same query in Athena, which is slightly different. I will show you. So instead of doing a top 5, you will apply a limit 5, right? It's exactly the same query. So you take this query and run it against Athena. So you remember every time you run this query, Athena counts minimum as 10 MB. So for that 10 MB, the charges will be imposed. All right. So here is the same output that we were checking here on SQL Server, right? So we have successfully migrated all those 5 tables into S3 storage area, but we just created 2 tables. You can create tables similarly for other tables as well. It's very simple, as you see, right? It's just one time effort. You create the table and start running all your queries. And one important thing here is on the settings, you have something called as query output location. So this is the location where it will store the result of the query temporarily, just in case if you want to rerun, sorry, if you want to check this query output in a later time, so that you're not charged for querying that table again. Right, so that's all, guys. Thank you for watching, and I hope you learned it. Give me a thumbs up if you really liked it. Drop in your questions on the comment box. I can reply to your questions whenever I get some time. So yeah, so this is the way you dynamically migrate all your SQL data into cloud. Thank you.